Okay, now on to part 2. So we've got find a rectangular equation given the parametric equations. These next two are the same exact equations that we graphed, so I want to show you the second part that we can do with this. So we've got x equals t squared minus 4 and y equals t divided by 2. So we want to find it in rectangular equation. We want to find it as a rectangular equation. So that means x's and y's only. And it says, so x's and y's only. All right, and it says equation, it's only one equation we want. Right now we have two equations where each x and y are defined by t. So we want one equation, a rectangular equation, and we want it only with x's and y's, no t's involved. Okay, so what we're going to do is, one of the approaches that we can use is we look at our two equations and we say, all right, can I solve for t for any one of these? So I could actually probably solve for t for either one, so I want to pick the one that's easier. If I try and solve for t with this x, we've got a square root that we'll have to do, which is going to be like a plus or minus, an e. We don't really, that's not the easiest. The easiest one would be to solve for t using this second equation, which would be, I just multiply by 2, so I would get t equals 2y. Okay? So now once I have what t is equal to, I can go to my equation for x and I could say x is equal to t squared minus 4. But instead of t, I can plug in what t is equal to, which is 2y. Okay? And now what we want to do is we want to go ahead and simplify that. So we've got 2y squared, so that's going to be 4y squared minus 4. So x is equal to 4y squared minus 4, and we don't have to have it as a y equals because x equals 4y squared minus 4. We've done equations like this before. This is a parabola, and it opens to the right. Just like we saw up above when we actually graphed it out, we saw that it was a parabola opening to the right. But now we have the actual equation of the parabola by finding the rectangular equation by canceling out the t. All right, so we're going to do the same exact thing with the next one. We want to find a rectangular equation using the given parametric equation. So the first thing I want to check and see is, can I solve for t? Yeah, it looks like both x and y have the same level of difficulty in terms of solving for t. So I'm just going to go ahead and approach it with the x. So I'm going to subtract 3 to get that t by itself. So we're going to get x minus 3 equals negative 2t. I divide everything by negative 2. So I'm going to get t equals, I'm going to write that as negative 1/2 x, and then negative over negative is a positive 3 over 2. Okay, so now I have what t is equal to. So I can double to my other equation. All right, so we go to this other equation, the opposite equation, and we say, all right, y equals 2 plus 3t. But instead of t, I'm going to take t and I'm going to plug it in. So I'm going to plug negative 1/2 x plus 3/2. Okay? So now I go ahead and I simplify just like I did before. I'm going to distribute that 3 in. So I'm going to do y equals 2 plus negative 3 over 2x plus 9 over 2. And then I can simplify this further. This is 2 over 1. So in order to add, we're going to do y equals negative 3 over 2x. and then 9 over 2 plus 2 over 1 multiplied by 2. So we get plus 13 over 2. So we get y equals negative 3 over 2x plus 13 over 2. There's no longer any t's involved in that equation. And when I look at that, that's a linear equation with a negative slope. So if I double back up here and I look at my graph of what I just did, yep, that's a negative slope. Does it go down 1, 2, 3 over 2? Yep, it's got a slope of negative 3 over 2. All right, and that's how we would approach these ones. All right, now on to the ones where we actually didn't have a graph of it. So we're going to talk about what to do in these cases. All right, so we're going to do the same exact thing. We're going to look to see, can I solve for t? Ooh, so we've got e. So, all right, yep, I can solve for t. So what I'm going to do is I'm going to actually use y because x has e to the 2t, and then y is just plain old e to the t. So I'm going to solve for t by getting rid of the e, ln both sides. Oh, I'll change my color because I've been solving for t using the red. So let me just change and keep it consistent. So I take the natural log of both sides. So we're going to get t equals, because remember when you take that t and bump it down in front of the ln and the e are going to cancel out, ln of y. So I go ahead and I fill that into my equation. X equals e to the 2 times t. But in this case, my t is ln y. All right, now we're going to do a little bit of razzle dazzle. You ready? Now, we want to simplify. We can't simplify this yet because the e and the ln are not right next to each other. Okay? We can't simplify this just yet because the e and the ln, because right now we have e to the 2 ln y. The e and the ln are not right next to each other, so we can't simplify it, but yeah, we can. We can simplify this further. Here's a little razzle dazzle. You ready for this? Well, buckle up. We've got a 2 in front of an ln. The properties of logs say I can relocate that back to the exponent. So now we have x equals e to the ln of y squared. All right, now e and ln are going to cancel, so we are going to get x equals y squared. Final answer. Wow. All right, so that's a parabola. Opening to the right because it's positive. Okay. It looks kind of like a C that I drew. Let me make that so that it looks more like a parabola. There we go. All right. So on to the next one. Hang on. Before I go to the next one, I want to show you a little trick. Okay. So we could have gotten to this answer using another method. Okay. You ready? I'm going to show that over here. There's an easier approach to this question. Maybe easier approach. We'll see. All right, so for this one, we've got x equals e to the 2t, and for y, we've got e to the t. Now, they kind of have that e to the t in common. So if you notice that, you've got x equals, I could rewrite this because I've got 2 times t, so I could write that as an exponent raised to an exponent, because then that would become 2t. And then that would be, fill in your y, because y equals t e to the t, x equals y squared. Boom. You can also have looked at this Another way, you could have said, all right, if I take y equals e to the t, and then I want to get it so it says 2t, so I can square both sides, and then I get y squared equals e to the 2t. E to the 2t is x, so y squared equals x. So there are a bunch of different ways that you could approach this, guys. So one of them is just seeing like, oh, I can substitute in without having to solve for t. So that's what we're going to look to see in the future. Is there a way that I can look to substitute in for the t? Okay. So I'm going to pause right here before going on to example 5.